Let's solve chemistry. The first question is number 33. A mixture of 0.3 mole of nitrogen. This is nitrogen gas, right? We're gonna start like writing the moles here, just not to lose any information about it. This is pretty. Okay, so 0.3, I'm gonna 0.3 mole of nitrogen plus 0.5 mole of CO2 and plus here 0.4 mole of oxygen exerts a pressure of, so the total pressure is going to be 2.4 atm on the walls of a vessel that contains it. So he didn't specify which vessel is it, so I'm going to draw a generic one. So this vessel has a pressure of 2.4. So he's asking, what is the pressure exerted by the nitrogen? 2.4 is the total pressure, and we're going to have 3 different molecules here inside this vessel. The total pressure exerted by the nitrogen is going to be proportional to the amount of moles of nitrogen. So if we have 2.4 atm as the total pressure, and how much is going to be the total number of moles of molecules inside this vessel. So we have to sum up all these numbers here. So 0.5, oh my gosh, here 0.5 plus 0.3 plus 0.4, this is going to be a total of 1.2 moles. 2.4 atm, let me just put it up there to make some space here. It's gonna correspond to the total amount of moles here, 1.2 mole. And I want to know how much is the total pressure of oxygen. And we have 0.3 moles of oxygen. So 0.3 is gonna come up here. And we just multiply this, crossing the numbers. We're gonna have here 1.2 x equals 2.4 times 0.3. This is going to be 0.72. Then we're going to have 0.72 divided by 1.2. This is going to be, if we divide by 2 both numbers, we're going to have 0.36 divided by 0.6. If we multiply by 10, both numbers, we're going to have 3.6 divided by 6. This is going to be 0.6. The answer is going to be 0.6 atm. This is the partial pressure of nitrogen. 0.6 atm. Okay? All right. The first one we've done. Now let's go to the second one, the 34. I'm going to just make some space here for the next question. All right, there you go. A gas confined in a rigid cylinder. So we're going to have to draw a cylinder. Oh my God, I'm not that good in drawing. All right, just use your imagination because this one is my rigid cylinder, okay? All right, a gas is confined in a rigid cylinder and maintained at a temperature of -3 Celsius. Exert a pressure of 9, so the temperature is going to be -3 and the pressure is going to be 9 atm. What pressure would the same gas exert if it were heated to 27 Celsius? All right, so here we have to use the famous formula of pressure times volume divided by temperature equals pressure times volume divided by temperature. So the final pressure times the final volume divided by the final temperature is going to be equal to the initial pressure times the initial volume divided by the initial temperature. The initial temperature is going to be minus 3 Celsius. For this formula, we have to use Kelvin. And how do we convert Celsius into Kelvin? We have to sum up 273. So Kelvin is going to be Celsius plus 273. Kelvin is going to be minus 3 plus 273. Kelvin is going to be 270. So this is my initial temperature. All right, there you go. I'm going to put it already here. And my initial pressure, 9 atm. My initial volume, another important thing here is he told us that it is a rigid cylinder. So the volume is not gonna vary. It's gonna be constant. So we can just take it out, all right, from the formula. Just because the final volume is gonna be equal to the initial volume. If the final volume is equal to the initial one, we have to just cancel both of them, all right? The final temperature is going to be 27 Celsius. Again, we have to convert that 27 Celsius into Kelvin. So K, Kelvin, is going to be equal to 27 plus 273. This is going to be equal to 300 Kelvin. This is the final temperature. The final temperature is going to be 300 Kelvin, and we want to know what would be the final pressure. Again, we're going to just pass this 300 to the other side of the equation, and I'm going to use this space down here, and this is going to be the final pressure. This is going to be equal to 9 times 300 divided by 270. This is going to be 2700 divided by 270. We can cut 1 0 both here above and below, and then divide by 27. This is going to be 10 atm. So this is going to be our final pressure.